This is Jack Jackson. We're going to be looking today at the side-angle-side condition. So what we want to do here is to say if we specify two side lengths that are going to be lengths of sides of a triangle. And we also specify the angle that's formed by those two sides. Does that specify the rest of the triangle, or do we have choices? So basically in this sketch it's operated by sliders. This changes the length of A, this changes the length of side B, and this changes the length of angle C in between. So if we're doing this by constructing it ourselves, we would pick an angle here. It can be an obtuse angle or an acute angle. And that specifies this angle. And so we now have the one vertex C specified. Now we take this side of the angle and we pick a length to go out. Let's say this length B. Notice that means it's that length from this vertex C, so the vertex has to be somewhere on that circle, but it also has to be somewhere on this ray, which leaves only one possible location for it, point A. And similarly to find B, we go out a length A, which is specified by the blue circle. Those are all the points that are a length A from C. But it also has to be on that ray, which only leaves point B. We could have alternately picked our triangle going from this point where it's on the green circle and that ray, and then the blue one here, and then back. But what we see is that these two triangles here are just mirror images of each other around this line going from from here to here. Mirror image over that. So it really didn't matter which one we picked. We still get congruent triangles. So notice that there's all the measurements. And so we see that this works out. If we were to make a congruent triangle down here, we know that these two blue sides are congruent, and the red angle and then the green sides are congruent. And it turns out that's enough to make the entire triangle congruent. And notice these are both affected by this angle and this side. Another thing that is interesting about this, as we notice, is that there are really no exceptions to what's going on here. No matter what we pick for this angle, we can start with any proper angle as long as it's less than 180 degrees and greater than 0, just a real regular angle from a triangle. That specifies the angle. So that specifies the ray there. And really it doesn't matter what we picked, any positive value, all the way real close to 0 or really way out here, this circle here is going to intersect that ray in exactly one place. It has to intersect it once and only once. Similarly, the ray that we have over here and then the circle for the other side are going to intersect each other once and only once. So there's sort of no way to mess this one up. We can make up any two lengths we want and any angle measurement in between, and that's going to be enough to completely determine one size of triangle. So our conclusion is that we have there are no exceptions. Any two lengths and an angle that you pick will give you exactly one triangle up to congruence. In other words, there may be a different triangle, it may be in a different place down here, but we can move it and put it on top of the other, perhaps with this translation or rotation or reflection or a combination. So the side-angle-side postulate says if we are given two triangles with two pairs of corresponding sides congruent, and the pair of included angles are congruent also, then the two triangles must be congruent, which means that the other pair of corresponding angles and both other pairs of corresponding angles and the other pair of corresponding sides must also be congruent. So you sort of get three things for free. If you get the three things, specifically side, angle, side, to be congruent to begin with, then you get the other side and the other angles congruent as well. Okay, so that's the side-angle-side postulate. Now this actually is a postulate. This is a little harder to explain why, but it turns out there are other geometries besides Euclidean geometry where the side-angle-side postulate does not work. Those are not the kind of geometries we study in elementary geometry course or a trigonometry course. So for our purposes, this must occur. But there's no proof of this. This is one of the basic building blocks of how Euclidean geometry works. So this is actually a postulate, the side-angle-side postulate. So again, the side-angle-side condition is enough to determine that we have exactly one triangle.